Okay, everybody, we're going to have a little special episode here. Some of you might be interested in or have some machinery or have a shop set up of your own at home or something. A long time ago, I set up in my garage my operation of what I was going to do. I had a lathe and a mill and a saw and a surface grinder, a few basic machines, but I didn't have three-phase electricity to run my machines. Primarily, the machine tools that we use in machining run off of three-phase electricity. So I'm gonna tax my memory here and try to remember some of the things that I did to operate my machines. I did not have three-phase electricity service to my garage, so I had to improvise, and I put in a phase converter. So remember that word, phase converter. All my machines were 220 three-phase motors. We talked about three-phase motors in one of our very first videos. The motor on a milling machine or a drill press, you can go from forward to reverse instantly. You have to do that sometimes when you're tapping a hole, threading a hole. You want to run the tap down in, then unscrew it. So going forward and reverse instantly is what those machines are made to do. But you have to have three-phase electricity. If you don't have three-phase electricity, you can go down and tap a hole, but then you can't reverse it most likely. And if you're buying a used machine or an older machine, not CNC, this is primarily geared to talking about not CNC machines, because they're so finicky with the voltage they need. You got to be plus or minus a couple percent on your voltage to run CNC machines. On the older machine tools, they're pretty forgiving. So let me explain three-phase electricity as I see it. And I'm not an electrician, so I'm going to put that disclaimer out there right now. I'm not an electrician. I did what I had to do to get power to my machines. If you are a little nervous or unfamiliar with electricity, I would strongly suggest getting an electrician to help you out. But here's how I did it. So I had 220 single phase at my house, and I needed 220 three-phase. 220 single phase has, and you may have different power grids in your wherever you're at. 220 single phase is two electric lines that are hot. They're 110 volts each, and then you've got the neutral or the ground. I'm not sure which the designation is correct for how it's named. Anyhow, to get three-phase electricity to my machines, I had to use a phase converter. So there's a couple different kinds of phase converters. One is a static phase converter. It's a little box that will give your three-phase motor enough of a boost to get it running, and once it's running, the two phases will generate the third phase, if that makes any sense. But when it generates that third phase, typically, I'm going to check this here in a minute on my outlet for a true three-phase service. You've got the ground to one leg is 120 volts, ground to another leg is 120 volts, and then in three-phase, true three-phase, you're going to have a ground to another leg, that's the high leg, that's 240 volts. But if you check across the two 120 volt lines, you got 240 volts. If you check across the 240, the high leg, and one of your low legs, it'll still be 240. All three, no matter how you measure across them, will be 240, except for the neutral or the ground. So a three-phase plug has four prongs on it, and when it's wired up, the one prong has a little tag on it, or flag on it, that when you plug it in, it goes into a specific part on your receptacle. So you only that's your neutral. So you're always going to get your voltage plugged in here. So I'm going to come over here, and here's a receptacle here. This one right here has the little flag on it. So we're going to plug this thing in here, and this is a twist lock. I put it in, and then I turn it, and it locks that thing in. It's good and tight there. So that's how three-phase machines get wired. When I did my wiring, I took the two 110 legs, and like I said, you either have a static converter or a rotary converter. A rotary converter is one that has a motor that starts turning and spinning. It's powered by electricity to get running. Once it's running, it manufactures that third leg that you need to run other machines. So you can have a power source generating three-phase electricity by having that three-phase motor. Once you get it running and put the electricity to it, you will supply your outlets with three-phase electricity. I happen to put a monster motor in my garage. It was a 10-horse motor, so if I wanted to, I could run any combination of machines as long as the horsepower didn't go over 10 horse. I never even approached that. I probably could have got by with a 5-horse motor, but I didn't know what I was doing real well. But that's what I use. So anyhow, what I'm telling you how to get three-phase service, because if you go out and want to buy a machine and you get it home, or you look at it and it says, oh, this is a three-phase motor on here. If you don't have three-phase to run it, what do you do with it? You just bought it, you can't use it. Well, here's a three-phase system that you can use to run that machine. Now, I will say, you know, you're wanting to get, I'm gonna show you some voltage readings here. I got my voltage tester here, and I might look like an electrician with this voltage tester here, but I am not an electrician. But I'm going to show you what I had to get my machines to do. Here's a regular household outlet. You know, this thing here's the meter is here. It's going to deflect up there. I've got to set it. It measures a range of 1,000 volts. So I'm going to put this in my neutral or ground, and I'm going to put this in one of the flag holes in the receptacle. It doesn't do anything. But if I put it over here, the needle moves. Okay, so this is the hot leg here to ground. If I go across the two, I will get the same reading, maybe even a little bit higher. So that's single phase electricity. I'm telling you again, I'm not an electrician. I'm out of my field of expertise, but this is how the machines work off of three-phase electricity. And I wanted to get a machine shop going in my garage, so I figured out and got some advice on how to do it. So anyhow, so that's household receptacles. Here's a three-phase receptacle, and this one that's got the flag is the neutral or the ground. And I'm not sure if that's the right terminology for it. I'm going to put my red lead in here in this one, and if you look at the meter down there, it goes up to about the same place the meter went on the bottom one down there. I take that back. That's higher than mine, but the first one. Here's the lower leg. I'm in the neutral position with the black lead. I've got this one in the top slot, and it registers somewhat below 50 on there. That means 120 volts just on the scale. If I go to the next one to the side, it goes to the same place it was just at over there. But now if I go to the third one, that needle goes way past the 50 on the scale. This is an analog meter. They got digital ones now that you can use, but this is what I use. Okay, so from the ground to here is 240, 120, 120. Now I'm going to measure across these things, and I've got even a little bit higher than what I had when I measured it singly. And I'm going to touch between the two here. No matter how I plug across these three hot lines here, I'm getting 240 volts three-phase. With a phase converter that we were talking about, that reading that you're going to get on the high leg is only going to be about 180 volts instead of 240. So you're going to be short of true 240 volt or 220 three-phase by quite a bit. But old motors and old machines that are not CNC, that don't have to be that fussy, they work fine with that. So you're not losing anything. Now, when you turn on a machine, when you first wire it up, you might turn it on and it's going backwards. Oh boy, what do you do then? It's running the wrong way. So if we look back here in this, there's a service disconnect box right here on the bottom of this machine, and I've got this guy unplugged. It's not hot, so I'm gonna look into this box right down here, and you can see my wires here. There's a green wire, that's the ground or the neutral, and then I've got red, black, and white lines, and they go into the fuse block. And the red wire is usually the high leg, and the other two are the low legs. So if you turn on your machine and the spindle or the rotation goes backwards, all you have to do is switch to any two of those wires. Just switch them, and then your rotation will change to the correct rotation. Now on this old saw here, we have a coolant pump in there, and we've tapped onto one of the legs here to get our coolant pump powered. If you got and most coolant pumps will run on a household current. I'm probably telling you something that doesn't work per code, but this is you can take a little leg off of here and get your receptacle for your coolant pump, but make sure you take it off of one of the low leg voltage lines to power your pump, because otherwise that thing will pump like mad for a few seconds and probably burn out. So three-phase is for switching directions on spindles, like when you're drilling and tapping a hole, but in case like on a saw, that blade is only going to go one direction when it cuts. If it's going backwards, just switch two of the wires. And again, get an electrician to do it for you. If you are anywhere concerned that you're not sure what you're doing, get an electrician. I don't want anybody getting fried, and it wouldn't look good. You can see my hair is still straight. I didn't get it sizzled or fried, so I was cautious. I got some help when I needed. I had a guy make me a static converter. I forgot to tell you about the rotary converter. Is a machine or a device that turns and gets your electricity generated to you, but you can take a three-phase motor and have another motor attached to it with a pulley and get it started by the single-phase motor. Just get that three-phase motor spinning, throw the juice to it, and it will generate your three-phase. Now again, that's something for a motor shop or an electrician to help you with. But anyhow, I just wanted to tell you that in case you're interested or you run across a machine you want and you don't have three-phase. You can make a phase converter. You can buy one, make one. You got to improvise a little bit, but there's ways to do it. So Maker's Machining is going to give you pointers here and there, and this is one of them. And I'm not an electrician. I don't know how many times I've said that. Get help, but you can make your machines run. Now that's unless it's a 440 volts or higher, then I've got no help for you, or a DC. A lot of old military or naval machinery is all DC, so that's a whole different animal. But for the general machine tools, the older ones, the manual machines, the three-phase is what they usually have. So anyhow, good luck with that. If you're so inclined to get a little shop set up in your garage and have all your machines there, that's one way you can get them powered. So anyhow, this is Tim at Maker's Machining signing off again here. Feel free to share this and like if you would. We're getting a bigger following here every week, so keep us on the share list too with your friends. So anyhow, we'll talk to you again here before long. Bye-bye.